Hi, I'm Murdy, but a nerdy Murdy. This is the part 2 of the series about creating a new programming language. In this video, I will show you the syntax of the future. Before starting to explain the syntax, in the first video, I have told you that we are going to create a new programming language called X, right? So let me reveal a secret to you. But you have to promise me to don't tell anyone. Surprise, surprise! The language X was actually none other than the chaos languages itself. Now we can start. Describing a language's syntax without giving a hello world example would be a dull affair. So this is how will you print the hello world text into the screen. The print statement and a string literal. By the way, chaos and the greater than sign is the interactive shell indicator. While comments have no effect on the grammar, it is one of the most fundamental features of a programming language. So in the language we are going to develop, the single line comments can either start with a double forward slash or a number sign. For multi-line comments, you have to wrap your comment with forward slash, asterisk, and asterisk forward slash. The keyword for Boolean data type is bool. So to declare a Boolean type variable, you prepend a bool keyword to the variable and continue with the assignment operator equal sign and finally the corresponding Boolean value true or false. The keyword for number data type is num. So to declare a number type variable, you prepend a num keyword to the variable and continue with the assignment operator equal sign and finally the corresponding integer or floating point number like 5 or 3.2. The keyword for string data type is str. So to declare a string type variable, you prepend an str keyword to the variable and continue with the assignment operator equal sign and finally the corresponding string literal like string 1. The keyword for any data type is any. The any data type is a little bit different than the others. While we define the syntax as a type-safe syntax, as you can understand it from its name, any data type can hold a value from any other 3 primitive data types, so it is not type-safe. The keyword for list data type is list. So to declare a list type variable, you prepend a list keyword to the variable and continue with the assignment operator equal sign, and finally the corresponding list elements wrapped in square brackets like 1, 2, and 3. While the end of line character for our language will be \n, unlike the languages that uses semicolon as the end of line character, like PHP, C#, and Java, it is possible to parse multi-line lists with some tricks. So this is how the multi-line list definition will look like. Accessing the list elements is pretty standard. You just wrap the index of the element with square brackets, then append it to the variable's name to access a list element. We will also support negative indexes. Updating list elements is quite similar to accessing them. Just access and assign a value to that element. Similarly, to delete a list element, just put a del keyword in front of the list element accessor. It will be also possible to create typed lists by prefixing list keyword with a primitive data type. And we will also support multidimensional lists like this. The keyword for dictionary data type is dict. They are quite similar to the lists in terms of how they work, and they are basically JSON data type. So I will skip them quickly. Instead of accessing by indexes, you access the dictionary elements using keys. You can check out this link to see more examples. Relational operators will be exactly the same as the relational operators in C language. Equal, not equal, greater than, smaller than, greater than or equal, smaller than or equal. Logical operators will be a combination of the logical operators in C and Python languages, and, or, not. Bitwise operators will be the same as the bitwise operators in C language. Binary AND, binary OR, binary XOR, binary ones complement, binary left shift, and binary right shift. We'll also support unary operators like parentheses, pre or post increment, and pre or post decrement, just like in C language. The loops in our language will be predeterministic, which means there will be no conditional loops. Rex language is an example to that kind of a loop syntax. As you can understand from the naming, n times do loop runs the code inside its block n times. In this case, it prints hello world 3 times. You can also use a number type variable to specify the iteration count. There will be also an infinite keyword to achieve infinite loops if it is really necessary. For each as can be used to iterate over the elements of a list or a dictionary. We'll also support nested loops. Break and continue statements will be a little bit tricky. You'll have to understand how decision making will work in this language. But I can say that when the criteria is met, in the call function, you will be able to break or continue the loop. Using break and continue statements directly inside the loop will not be possible. Functions in our language will be quite similar to the functions in Python and Ruby in terms of the syntax. There will be no need to forward declare functions because the interpreter will look ahead. All of the functions in our language will be forced to have one of these keywords to determine the return type: bool, num, str, list, or dict. This is an example to a function that returns a typed list. Decision making, aka control structures, in our language will be only achievable on function returns for the sake of zero-cyclomatic complexity. For example, if you run this program, the output will be 101 because z equals 8 is a correct statement. It changed the return of a function f1 into the return of function add. You can think this block of code as a traditional switch case statement with break in every case block. You can get more information about decision making from this link. We'll also implement a simple module system. It will just load up the functions in the file from the specified path, and you will be able to import a module or specify the functions you want to import using this syntax. Eventually, the whole syntax of a program will be looking like this. You can get a syntax highlighted, a full example, by following this link. That's it for today. Hope to see you in the next videos. Don't forget to subscribe, like or dislike, and maybe ring the bell if you will. Bye bye!